Hello students, hope you are doing well. In this video we are going to discuss route redistribution of Unit 5, designing IP addressing in the network and selecting routing protocol. For the subject Enterprise Network Design of B7 semester IT, University of Mumbai. In this lecture we will discuss using route redistribution, administrative distance, selecting the best route, route redistribution direction, route redistribution planning, route redistribution in the enterprise architecture. There are possible reasons why we might need multiple routing protocol running at the same time within our network. You are migrating from an older IGP to a new IGP. Multiple redistribution boundaries might exist until a new protocol has displaced the old protocol completely. Running multiple routing protocol during a migration is effectively the same as the network that has multiple routing protocol running as a part of its design, because older protocol is also present in there and new protocol is also implemented there. You want to use another protocol but have to keep the old routing protocol because of the host system's need. For example, Unix host-based router might run only RIP. Some department might not want to upgrade their routers to support a new routing protocol. If you have mixed vendor environment, you can use the Cisco proprietary EIGRP routing protocol in the Cisco portion of the network and then use common standard based routing protocols such as OSPF to communicate with non-Cisco devices. So when any of these situation arises, Cisco routers allow inter-network using different routing protocol referred to as routing domain or autonomous system AS to exchange routing information through a feature called route redistribution. This allows like a host in one part of the network to reach host in another part of that is running a different routing protocol. So in some cases the some protocol may be used in multiple different domains or autonomous system within the network. Okay, multiple instances of the protocol are treated no differently than if they were distinct protocol. Redistribution is required to exchange routes between them. Accordingly, redistribution of route is required when one or both of things occur. First thing is multiple routing protocol are used in the network. For example, RIP version 2, EIGRP and OSPF. Or multiple routing domains are used in the network. For example, 2 EIGRP routing processes. Redistribution occurs on the boundaries between routing protocol and between domains. So in this figure, you can see that redistribution occur on a router with interface that participate in multiple routing protocol or routing domains. So it shows the multiple routing domain and it shows the multiple routing protocols. Administrative distances. Most routing protocol have metric structure and algorithm that are incompatible with other protocol. It is crucial that a network using multiple routing protocol be able to seamlessly exchange route information and be able to select the best path across multiple protocols. Cisco routers use a value called administrative distance to select the best path when they learn of two or more routes to the same destination from different routing protocols. Administrative distance rates routing protocols believability. Cisco has assigned a default administrative distance value to each routing protocol support on its router. Each routing protocol is prioritized in order from most to least believable. Administrative distance is a value between 0 to 255. The lower the administrative distance value, the higher the protocol's believability. So believability is very high in case of low distance, low administrative distance. So here are some example, like connected interface has value 0, static route to next hop is 1, external BGP 20, IGRP 100, integrated SS 115, EGP 140, EIGRP 170, unknown 255, highest administrative distance. Okay. Similarly, internal BGP 200, on-demand routing 160, RIP version 1, version 2 120, OSPF 110, internally IGRP 90, EIGRP summary routes 5, and static route out and interface is 0. So these two are most believable. Okay, and these two are least believable. Fine. Now come to selecting the best route. Cisco routers use the two parameters to select the best path when they learn two or more routes to the same destination from different routing protocols. So first thing is administrative distance, okay, and second is routing metric. So let us discuss each one by one. Administrative distance, as already discussed, the administrative distance is used to rate a routing protocol's believability. This criteria is the first thing a router used to determine which routing protocol to believe if more than one protocol provides route information for the same destination. Then come to routing metric. The routing metric is a value representing the path between the local router and all destination network according to routing protocol being used. The metric is used to determine the routing protocol's best path to destination. Route redistribution direction. Redistribution is often applied between campus core and enterprise edge protocol. Okay, so campus core and enterprise edge protocol. In this figure, you can see, and there are two ways possible for a route redistribution. First is one-way route redistribution, and second is two-way route redistribution. Okay, one-way or two-way. In case of one-way route redistribution, what is the thing? Routing information is redistributed from one routing protocol to domain to another, but not vice versa. Static or default routers are required in the opposite direction to provide connectivity. In case of two-way routing, route redistribution, routing information is redistributed from one routing protocol or domain to another and vice versa. Static or default routes are not required because all routing information is passed between two entities. Specific routes can be filtered, and the administrative distances of redistributed routes can be changed in either of these cases to reduce the possibility of routing loops and ensure that the traffic is routed optimally. So here you can see that campus core protocol like OSPF and EIGRP is there, and several other protocols at enterprise edge module is there, and this is the way. If one way is there, then either one is used but not vice versa, and in case of two way, both the things are used. Now come to second thing, route redistribution planning. When deciding where and how to use route redistribution, determine these things. First thing is the routing protocol and domain that will use in the network, the routing protocol and domain boundaries. Okay, here domains and protocols and domain boundaries, the boundary routers, and third thing is the direction of route redistribution, one way or two way. Fine. If route redistribution is not carefully designed, Suboptimal routing and routing loops can be introduced into the network. When routes are redistributed in a network with a redundant path between dissimilar routing protocol or domain, route filtering helps to solve this problem. Route redistribution in enterprise architecture. So this shows the enterprise architecture. Okay, campus core, building distribution and access layer is there. And this is the enterprise edge module to PSTN to internet to WAN and to WAN. So this is very important module for redistribution of the data. Redistribution is needed in the building distribution layer when different routing protocol or domain exists in the building access layer and campus core layer. Redistribution might also be needed between campus core and enterprise edge, including to and from WAN module routers, from static or BGP routers in the internet connectivity module, and from static routes in the uh, remote access VPN module. In this figure, a simple enterprise network with redistribution point is given, and these redistribution points are throughout the network. In this example, some remote sites require connectivity to the server farm. Okay, so it requires the connection from server farm. Fine. Therefore, one-way redistribution is performed to inject routes from these remote sites into the campus core. Some remote sites require connectivity to entire network. This is provided by two-way redistribution. Otherwise, static routes would have to be configured in campus core. The building distribution layer propagates only a default route down to the building access layer, whereas building access layer advertises its own subnet to the building distribution layer. Redistribution might also be necessary in remote access and VPN and internet connectivity module. For a remote access and VPN module with static routing, static routers are injected into the campus core routing protocol in the opposite direction. Default routes provide connectivity for remote users. In an internet connectivity module with only one exit point, that exit point is the default route for traffic destined for the internet and is propagated through the core routing protocol. If multiple exit point towards multiple IP ISPs exist, BGP provide internet connectivity and redistribution can be used. So here you can see that redistribution with BGP require careful planning. For more detail, you can see authorized self-study guide building a scalable Cisco Internet Network DSCI third edition by Diane Terrace and Catherine Packett Cisco Press. Okay, so this will give you more detail about route redistribution. So in this lecture, we have covered route redistribution using route redistribution, administrative distance, selecting the best route, route redistribution direction, planning, and in the route redistribution in the enterprise architecture. Next lecture, we will discuss route filtering. So thank you very much. Bye bye for now. Have a nice day. Have a nice time.